Well, here we go in a new project. What we are going to be building is a Dutch auction of a NFT in Ethereum. A Dutch auction is an auction where the prices goes down with the time. So we are going to be auctioning a whole NFT collection. It is going to work in a way that when we mint a new NFT, well, we are just going to deploy the contract of the NFT, and the users are going to be able to mint their tokens in accordance to the time, and the users that mints first will get a higher price than the ones that mint left at the last. So first we need to import the libraries for the basic NFT on Ethereum. These come from OpenZeppelin, and they provide us with the standard functions needed for the NFTs. Then we start our new contract. We are going to call this NFT Auction. We are going to, it is going to be an NFT, an ERC NFT. So we inherit all the functions from the libraries above. Ownable is a library that let us have rights and privileges depending of the role. The owner of this contract is going to be able to withdraw funds and to mint for free, but the other users that are not the owner will have to pay the fee and the price according to the time of the auction. We start defining our variables that are going to be used in this auction. Let's say that the starting price is 10 Ether, and the price is going to be slowly going down at this rate. And we want the auction to have a duration of about 7 days. And we, as the owners of the contract, are going to be able to say when this auction is going to start, and that's why we need this variable time start, and it's going to be a U unsigned integer as all of them. First, when a contract is deployed, there runs in the blockchain a special function called the constructor, and we pass the constructor some variables. We mark them as memory because they are going to be stored on the blockchain, and we initiate the ERC contract with these variables here. Since we want that always the price is positive, we assert that the initial cost, 10 Ether, minus the action duration by the rate is greater than 0. And we allow the users to mint their NFTs if they pay the price according to the time that they mint. So here we got the main function. It takes two arguments, takes the address where we are sending these NFTs, and it also takes the ID of the token that it's going to be minted. It must be payable because we are going to require that the sender of this function give us more than the cost. And how is the cost going to be computed? Well, we are going to compute the cost with a function called getPrice. That is going to be the core of the price logic. Here it is, getPrice. So we require for minting that time start is equal than 0, and we call the function price for set up the cost. The price is going to be a public function, a view function, because it is not going to alter the state variables, and also we don't want to pay any ether when we call this function. So the time start is going to be a time that is going to be fixed when the owner decides to start the auction. If the owner has not decided to start the auction, time start could be 0, because that's the default value of unsigned integer here. So if time start is 0, it will return the initial cost. But anyhow, the users will not be able to mint, because the owner has not decided yet to start the auction. That's why we are requiring that the starting time to be greater than 0. And the price is going to be, the formula for getting the price is going to be fairly simple. We require that the owner has decided to start, and we do that with this function. We here, let's add a little comment for having all our functions in an ordered way. Only owner. So only the owner will be able to start the auction. And at the moment that the owner starts the auction, we set the variable time start at the block time that this function is called. And we add the modifier here, only owner, because only the owner of this contract is going to be able to start the auction. Well, now that the time is positive, that the time start is positive, we require further that the actual time that this function is being called minus the time start be lower than the auction duration. I mean, if they have passed, if the auction has finished, we don't want the users to be able to mint. But maybe we would like to mint more tokens, so we add a special function that will allow only the owner to mint, And if you see, they can mint for free. We don't require the owner to pay any fee for minting. We call the function safe mint, that the safe mint function is defined here in the contract of the NFT. Oh, I see that I imported twice the same contract. Here we can see it. Here, if we look for the function saveMint, we see that this is an internal function that we are calling when we define our external mint function. So going back to our contract, oh yeah, here is saying, hey, where is my ownable contract? Yeah, now you are an ownable contract. So we have our mint function. We require that for anybody to mint a token, they must pay the cost. And how's the cost computed? The cost is computed with this very simple formula. We require that the auction has not finished. We require that the owner has decided to start the auction, and if that both conditions have happened, we then return the cost. And since I am saying here that that it returns a unit, well, I think it's fine. It might be that it does not return a unit, but in that way the transaction this required will not pass and the transaction will revert. So here are the function public for minting and the function for getting the price, and we must add another function so that the owner can withdraw all the funds that have been collected in the contract. This is a very basic function, withdraw. It must be labeled as payable, and we require that only the owner can call it. We use the method call on this address that we mark as payable, and we send the value stored in this contract address. When we use the call method for sending it there, we must add the signature of the function that is going to be called, and in this case there will be called the callback function, the fallback function, and we require that this transaction is successful, and I think that's all what it needs to happen. So let's check our contract. We save it, go here to the remix console, select the contract that you want to deploy. Here we pass as parameters the variables that the constructor is going to use. In this case, since we are initiating an ERC 721 contract, we must pass the name. So I will call this Alice NFTs. The symbol are going to be AL NFT, and we deploy the transaction. All this is happening in a local blockchain that runs inside your web browser. You can connect also your MetaMask, is on Remix. When we use this local blockchain, they give us some address for we to play with it, and here we see our contract deployed with all the functions that are defined on our script here. Here is the function that we defined. There are a lot of functions, more functions. For example, each state variable that is here has its own public function. Here we see the symbol, we see the rate at which the price declines, the owner, the name, the initial cost that we say 10 ether, the withdraw function, the mint function. So let's do a very quick test. When we deploy the ERC 721 contract as a default, well, I am sorry, when we deploy the ownable contract as a default, the address that is deploying the contract becomes the owner. So when we click here on owner, we get the address that deployed the contract, and this address can have access to these special functions. So for example, if we change address and then try to start the auction, we see that we cannot start the auction because we are not the owners. Only the owner can. If we try to mint a token, we must say where we are minting and the token ID that we want to mint. We cannot mint because we are not, because the auction has not started and because we are not sending any ether with it. So, but the owner can mint. If we change address, we see that the owner is going to be allowed to mint. And yes, the owner can mint tokens, and also the owner can decide to start the auction. If this is the initial cost, and if we try to get the cost right now, we get the price, we get the initial cost. Now let's start the auction, the dots auction. That's here, start auction. And the auction has been started. And now let's see the price. Oh, and we see that the price is going down. But what about if someone want to mint for free? Or let's say that he wants to mint but just paying the half of the price. Here we say how gas we want to send them? What about if we just want to send C5 ether? The price is set to 10 ether. So if someone wants to mint paying only 5 ether, he could not be able to do it. So we go here and let's try to mint the token number 3. Oh, he cannot mint. Why? Because he's not paying the price. So let's say that he pays the price. What's the price? Well, the price is going down. But let's try with this one. We put it here. And let's try to mint. And the transaction is pending. I hope it passes. Maybe the browser is getting a little bit slow. Sometimes it happens if you have a lot of open windows like I do. Oh, I think the other transaction has ended. Let's see if it was minted. We can check that with getting the owner of the token 3. Oh, I see that the owner is not this, so maybe the other transaction didn't go because I had already minted the number 3. Let's try with the number 6 and with the actual price. It could be this one. Oh, yes, the problem with the other one was also that I didn't put here the pricing way. Now that I have selected way, it should work. I tried to send a lot more ether. Oh. It's because there is not this thing here. Okay, and there we see we can mint if we are not the owners and if we pay the price. And as we see here, this address had to pay almost 10 ether, and this ether is now stored in the contract, and then the owner, once the auction has finished, can withdraw the funds. So we must change to the owner and then click on withdraw, and the owner has withdrawn the funds that were stored in the contract. And now we have here that the owner has 10 ether more in their balance. And well, that's a Dutch auction of a whole collection of NFTs on Ethereum. Thank you so much for watching. See you in the next one.